All right, there's other visuals as well. So I'm going to just touch on a couple of them here. But of course, there's a ton of different styles of graphs that you can do. So another kind of visual is called a stem and leaf plot. And it kind of gives you a similar visual to a histogram, although on its side using numbers. So I'm going to show you how to make a stem and leaf plot. It's easier just to see an example than to try to write steps for something like this. So we have the 40 students this time for their test scores, right? Now, with a stem and leaf plot, you basically break the number up. So for instance, with the 82, we sort of break the number and break that ones position off. So if you had a number over 100, you would still break off the ones place. That's typically what we do. So for instance, this example is not here, but let's say you had the number 125. Again, usually we're going to break off the ones place. And what you do is you create your first column, which has all of these leading digits first. So first of all, I have to figure out what my lowest value is and my highest value is in this group. So my lowest value here, I believe, is 43, which is right here. So I'm just going to make a note. So this is my minimum test score. And my maximum test score, I think, was 94? I have a couple 94s. So I'll just choose one of them. This is one of my maxes. So that 43 and 94, again, we're going to split off those ones places. So we're going to go from 4 to 9 in the first column. So it's going to look like this. So these are called your stems. So this is the tens place. So I have a 4 as my first one. Then I would do 5, 6, 7, 8, and 9. And we typically kind of draw like a little vertical line there. And then the other part are called your leads. And these would be the ones position. Now, this takes a long time to do because you have to go through for all the 40s, all the 50s, all the 60s, all the 70s, all the 80s, all the 90s. So for the 40s here, I'm going to go through. So I see 47, right? So I'm going to break that, and the 7 is going to go here under the leaf. So I have 47. Now I do have the whole thing done. I just want to show you guys a little bit more. So here's the 45. So I'm going to break it. So I have 40, and then the 5 goes here. I have 43, so 40, and then the 3. Right, and I think that is it. Now I'm going to do the 5s. So I'm looking for anything with a 50. So let's see, I see a 57. So the 5 is here, the 7 goes here. All right, I see a 54, so 5, 4. Now the hardest thing with these is it's so easy to miss a value. So that's kind of why I'm crossing everything out here too, is so that I know if I've used it. It just helps me kind of stay in track. So 1, 2, 3, I should have 6 here. I do, okay. Then I'm gonna do the 6. So let's do one more together. So I see 64, so I put the 4, 63, see 68, 66, 67, 66. Now 66 occurs more than once. I still write it more than once. All right, I think that's it. 1, 2, 3, 4, 5, 6. 1, 2, 3. Yes. Okay. So, and now I'm going to keep going down the line. So the others are going to be there too. Now, this is fine. So your book kind of leaves everything out of order like this. Really, you probably should put it in order if we're doing it correctly. So, hey, let's do the next one. So it's going to be 5, 6, 7, 9, 5, 3, 6, 4, 8, 6, 2, 2, 4, 8, 0, 0, 1, 7, 4, and then 3, 4, 2, 4, 4. So again, your book is allowing us to leave the values out of order. Typically, though, if you were taking a statistics course, you would actually put these in order. So you'd have it as 3, 5, 7, Here you'd have it as what, 0, 4, 6, 7, 7, 9. So you would put them in order. Your book doesn't care so much, so we'll skip that. But you do want to also try to space them well. So you kind of want to make columns as well as you're writing your data down. I know mine's not perfect, but you can kind of see I have some general columns here, so that you can see the lengths of those rows. So you don't want to just squish it all together. You want to kind of line up your columns. And then you can almost see, if I turn this on the side, it kind of looks like a histogram, right? It kind of looks like the different bars that we saw in our last example. So not that so you don't do this, but you kind of see how the bars, the heights of those bars form, right? Using that stem and leaf plot here. So this is a stem and leaf plot, and again, just a different visual, different way to help organize that data and really see where most of it occurs. So just looking quickly here, I can see that based on these two columns being, or two rows being the longest, most of my students had scores in the 70s and 80s, right? So if I'm looking quickly, let's say at my test scores, then I can see the 70s and the 80s seem to be pretty predominant as my two longest rows there. So that is your stem and leaf plot. Now, the last thing here, and I'm going to actually ask you guys to please watch these videos on your own. I don't think I need to play them here during this presentation. But one of the biggest things with statistics and with graphs is that it is really important that graphs are created in the correct way. There are a lot of really, really bad graphs out there. Graphs that are either just done wrong, so someone who made them didn't know what they were doing, or they're purposefully misleading, meaning that the person who created them did not do them ethically. They kind of tweaked things to make different parts look more predominant than others. So these videos kind of go through some different examples here on how we can be careful about graphs or just data in general, what to look for in graphs. So for this one here, 5 ways to spot misinformation, it just reminds you to do things like check the date of when the data came out, right? So if you're looking at something and it was published 5 years ago, that data may not be accurate anymore. Things may have changed. Look at who is publishing the information. Is it a reputable source? A lot of times things come out and the source may not be reputable, or it could be a joke, right? Sometimes there's joke files and joke sources as well. So those are just a couple things to watch for with your information. In misleading graphs as well. So, and I'll show you some things from your book. Things to watch out for are if graphs are missing titles, if they're missing labels, if your axes are not consistent. So maybe your x-axis is jumping from 1, 2, 3, then it goes to 10, and then to 12, and then to 15, and so on. So it's inconsistent. On your y-axis, I know I mentioned this briefly, but with histograms, you need to make sure that y-axis starts at 0. If it doesn't, then the bars are distorted. They're not the right proportion to the data. So it is important that the bars, when you look at a histogram or a bar graph, that they represent the correct height visually compared to how much data is there. And a lot of times that's one of the most common ways to make a misleading graph is to kind of squish that y-axis so that the bars are no longer the correct height. So that's another big one. Pictographs, so graphs that use pictures instead of bars as their visuals are actually really bad. So the things that we see in elementary school. But what happens with a picture is as it gets taller, it also gets wider so that the image doesn't get distorted. So again, even if your height is correct for the frequency, because it's so wide, it just looks so much bigger than it really is. So it's really important that your visual represents the actual data. And then let me show you a couple things here in your book. I'm just going to bring your book over to the camera. Okay. So here are some examples here. So this one looks at poverty rate, and you have the percents. And you can see here how the two different y-axes totally change the data, what it looks like, right? So the data is the same. Here, they're really spreading out their data points. So you can see you have a truncated axis here. We're starting at 11.3, and then it's 11.7, 12.1, 12.5, 12.9. So you have consistency here. They're going by 0.4%, but because the change is so small, it's really making the poverty rate look like it's drastically increasing when really it's going from 11.7 to 12.6. That's less than 1%, but this is making it look like a huge jump. On the contrary, this one is making it look like there's absolutely no change at all, right? So here you're going from 11 to 13 to 15. All of our data is between 11 and 13, so there's no need to go this high on the axis, and you're squishing your graph here. So this is bad because you're expanding your graph too much to show a trend that's really not as extreme as it's there. In this one, you're squishing your graph too much, so you can't see really any change. So you really want to be somewhere in between those two, right? So maybe we're going by ones or halves or something like that, maybe 0.75 change, but something in between these two would be a much better representation. We should see some change here, but it shouldn't be that drastic. It's only changing by 1%. Other examples, so I'm going to see if I can scooch everything over and show you guys these in your text. Okay. So here's a picture graph example. So we're using money to represent our bars here. And what happens is as the money gets bigger, so as the bar height gets bigger, the picture also has to get wider so the image doesn't get distorted. But it ends up distorting the graphic because the heights are correct, but this $1 bill here looks like it's like 3 times the size of 63 cents, and it's not, it's less than double, right? So by using a picture, because it gets wider as it gets taller, it just distorts the bars. So they should be in direct proportion to each other. So if this is 63 cents and this is $1, then this one should be about twice as big, right? It's about half, not quite. So it should be about twice as big, where this one looks like it's like 3 or 4 times bigger than this one. So they should be in proportion to one another. And you see the same thing here with this graphic down here. So they're trying to show how the average size of houses has been changing. And they are changing, right? So if you actually look at the data, it's there on the right here. You do see there is change. So we do need to show that. But using houses is not the way to do that. So they're kind of trying to show you the different size houses, and then they're getting these weird shadows. I think the shadows are supposed to represent the height, but I have no idea. I can't tell. There's no y-axis, so these numbers are just floating around in space. So these are bad graphs as well. Okay, so check out those videos. It's a really important topic, and there's really so many bad videos out there. So it does help to be able to recognize these things. So things to watch out for. Is there a title, right? And in general, are things actually labeled? Is your x-axis labeled? Is your y-axis labeled? Are the numbers lined up with the tick marks on the vertical axis that clearly indicate the scale? Has scale been varied to create more or less dramatic impression than shown by the actual data? So first of all, do you actually have tick marks, right? In the last picture we showed with the houses, there was no scale at all. And in the pictures we showed before that with the poverty rate, the scale was, one of them was really distorted to make the graph look like there was a lot of change, and the other one was distorted to make it look like there was no change. So you should not be distorting your axes. You should also make sure your marks are consistent, so they're going the same amount each time, right? Counting by ones or by halves, whatever it is. And sometimes you have to play around here. So you want to create a graph that accurately shows what's happening with the data. That's always the goal. Too many design and cosmetic effects draw attention from or distort the data. So sometimes there's just too much going on, right? There's just too many designs. Here's another one. 3D effects and graphs are just bad. They distort the data very, very much. So I would highly recommend you stay away from any sort of visual 3D effects and graphs. So that's a great example there that distorts the data. Has the wrong impression been created about how the data are changing because equally spaced times intervals are not used on the horizontal axis? Has a time interval been chosen that allows the data to be interpreted various ways, right? So again, are we manipulating the axes so that the reader thinks something's happening when really it's not as big of a deal as they're making it look? Are the bar sizes scaled proportionally in terms of the data? Again, your bar sizes should be proportionate to the data. So if one of your frequencies is 3 and the next one is 6, then one bar should be half of the next one. They should be the right sizes. That's really important. Is the source that indicates where the data came from displayed? So do you see a source? Is the data from a population or sample? What time frame did this come from, right? Was random sample used? Was it representative of the population? So was this actually a random sample, or was it a convenience sample where people got to self-select and decide if they want to take the survey or not? Who was presenting the data? Does the person have a special case to make for or against the trend? So could there be bias by the person creating the data, creating the graph, so that it shows that the data looks one way when really it's not as big of a change as they're showing, for instance, right? Other things we can do too is we can manipulate the data by only choosing years that we like. So for instance, if you go to that poverty rate example in your text on page 780, they actually have data there from 2001 through 2015, but the graph only shows the first 5 years. So we're just choosing the part that we want to display to everybody, but really there could be a bigger thing going on. So there are so many different ways to really manipulate visuals. So it's something that, again, I really want you to watch these videos just to kind of see. There's some good videos on to show you how data can be manipulated. This last video on coronavirus charts as well, it's not so much that the data was misleading, it was more so that people did not understand what they were reading. So that's equally as important, is that when you create graphs, you think about who your audience is and that they can understand what they're seeing. So there's things that are just blatant ways to kind of incorrectly make graphs. And then there's other ways where we think we're doing a good job, but maybe our audience doesn't understand the data that's there. So there's two sides we have to think about with it. So I hope you check out some of these examples and get a better insight about these bad graphs as well.